Hi everyone, I'm Michaela, and this is my research presentation on the macroevolution of cetaceans. Cetaceans are whales and dolphins and porpoises, for those of you who don't know. So, back before people really started studying animals and learning about them, people thought that whales were fish because they lived in the ocean like fish did. So when Linnaeus was doing all of his classification and observation, he noted that whales use lungs to breathe, not gills, and they were also warm-blooded. Most fish, all fish, aren't warm-blooded. So from these observations, he knew that whales and dolphins were mammals. They weren't fish. And so around that time, a little before maybe, there were fossils around that were huge bones, huge vertebrae, and people assumed that they were aquatic dinosaurs when they first discovered them, so that's how they had classified them. They called them Basilosaurus. But upon further investigation by a man named Sir Richard Owen in Britain, he compared these fossils to modern whale skeletons after it was confirmed that they were mammals. He compared their skeletons and he realized that these Basilosaurus fossils were actually ancient whales. They weren't dinosaurs. So as people found out about this, they started making connections with other fossils that they had found, and they started realizing that these other fossils were different transitional forms of whales transitioning from a land mammal to a fully marine animal like Basilosaurus. And they started making these connections. And so as people started making these connections, people started studying this macroevolution. So this is an evolutionary tree of what we now understand to be the transition, the macroevolution of whales from a land animal, which here is Pakicetus. That's the first identifiable ancestor. And from that animal to modern whales and dolphins. And so Pakicetus lived around the early Eocene period, and it lived on land all the time. It swam a little bit. It spent some time in the water, probably a lot of time. Being a land mammal, it probably spent a relatively long amount of time in the water. And over time, it started changing, adapting to be better suited to the water. So this fossil, Ambulocetus, is very crocodile-like. It was terrestrial, but it spent a very long, huge portion of its life in the water. It actually lived a lot like a crocodile does. It swam in the water, and it would actually hunt in the water. It'd sit on the bottom or on the edge of the water and wait for fish to swim by, and it would ambush fish. So the next two genera pictured here are members, I believe, are members of the family Remingtonocetidae, and they were amphibious. They spent a lot of time in the water, but they were still living on land as well. So the next two here, these two, are protocetids. Protocetids were about the size of dolphins, and they had very small hind limbs. They couldn't support themselves on land, so they spent the majority of their lives in water. A lot like seals today, actually. The way seals spend most of their time in water, but they're still terrestrial animals. And after them came the Dorodontidae and Basilosaurus, which were fully obligatory marine animals. They couldn't go on land at all. And so from them is where we get today's modern whales and dolphins. And from this transitional fossils and other methods like DNA analysis, we have actually figured out that all these different genera and groups of animals came from artiodactyls, ancient artiodactyls. They had to come from the same lineage. And artiodactyls also produced the modern hippos and deer, and cattle actually came from artiodactyls as well. So that we have discovered from DNA analysis. The whales are actually most closely related to hippos. That's their closest land relative. So they had to have a common ancestor. So some evolutionary changes that took place during this macroevolution that I've outlined are changes in the skull of whales. So this first picture here, these are pictures of different semicircular canals from several different species. A is the picture of an average land mammal's semicircular canals. As you can see, they're rather large. Land mammals use them for balance to tell what way they're oriented. And D, down here, that is the semicircular canals right here of cetacean species, modern cetacean species. And by comparison, they're extremely small. And that's because whales don't need to use them so much for balance. And having them large would actually disorient them in the water because of the way that they turn and rotate and swim. It'd actually be very disorienting for them to have large semicircular canals. So some other changes. Here we have teeth, the teeth of several different transitional species. These are Pakicetus teeth, which are very similar to modern land mammal teeth. They have two cusps, and that's a trend down to about the protocetids. But after the protocetids, with Dorodontidae and Basilosaurus, the teeth got a lot of littler cusps. This one has 4 here. Dorodontidae has 4 smaller cusps in its teeth. And they probably developed this because the teeth of Dorodontidae were better suited to holding on to fish and keeping hold of their prey. A few other changes in the skull. There's a structure in modern whales called a mandibular foramen in the lower jaw, and it actually picks up sound and amplifies it and sends it up the skull into the ears. So it amplifies sound heard underwater, so their hearing isn't impaired. And another change, as soon as marine mammals became fully marine, their brains started to increase in size, and nobody's really sure why that started happening. At least I couldn't find anything that confirmed why it happened. So their skull had to change to accommodate the larger brain. And one of the major changes to the skull was that the nasal openings moved from the tip of the snout in Pakicetus and Ambulocetus, and it moved up to the top of the head. It's at the top of the head by Basilosaurus and Dorodontidae, and that just makes it easier for them to breathe as they surface. They don't have to lift their whole head out of the water, just the top. So those are a few changes to the skull. Some other changes include the way that they swam and moved on land, their locomotion, and these locomotion changes accompanied the loss of hind limbs. So this first picture is Pakicetus, and it used, quadruped paddling. It's a lot like a dog paddle or like a way a bear might swim. And then there's Remington Remingtonicidae, and it has these hind limbs that were much more like flippers, like modern seals, and it actually swims a lot like modern seals, or swam a lot like modern seals do today, using pelvic paddling and pelvic undulation. And this next picture is a protocetid. Its hind limbs are very small, greatly reduced. It couldn't really use them to move on land too much. And this is Basilosaurus. Its hind limbs back here are very nearly gone, and it wouldn't have used them at all. And modern whales have no external evidence that they ever had hind limbs, although there is a few skeletal remains of them. So these last three moved using caudal oscillation, which is moving the tail up and down, and that gives them lift on the upstroke and on the downstroke, so that way they stay buoyant in the water. So it makes for a very energy efficient way of swimming. So why were all these adaptations developed? So the changes in locomotion were probably influenced by selective pressure to become more efficient swimmers, to catch prey better, and be more adapted to swimming in the water. So the caudal oscillation method that they ended up with in modern whales is very fast, very energetically cheap, and it's a very, very efficient way of moving through the water. So dolphins today are actually pursuit predators. They will chase fish until they catch them, and caudal oscillation allows them to do that. So the changes in the teeth also would allow them to catch fish more efficiently and hold on to prey once they caught it. So the changes in their ear structure and their hearing structure allow them to live underwater without too much trouble with the 3D environment, unlike terrestrial environments, which are not 3D. So it allows them to live in the water a lot easier. And the larger brain size, although it isn't clear why it happened in the first place, it allowed dolphins and whales to become problem solvers. And they can solve problems, and they can actually develop strategies to hunt prey together and catch more prey. So the conclusions of this presentation are, first of all, that the macroevolution of whales is very well documented, and it's been confirmed and studied more than any other macroevolution. And all this evidence and modern DNA and molecular methods have allowed us to 100% confirm that modern whales have come from archaeodactyls, and that they used to be land animals. So So modern whales and dolphins are actually very closely related to land animals, more closely than to fish or reptiles or dinosaurs or anything of that kind. So thanks for watching my presentation.